Big Dog Forge was filmed before a live studio audience, forging a 3D printed serpent in a seax. Alright guys, today it's an experiment. We are putting together a canoe canister, and it's made out of stainless steel to keep the steel from fusing to it. We're lining it with some 1095 on the sides, which will be our cutting edge and our backbone, wedging it in there with a couple of old bandsaw blade parts and pieces. And I did that because I wanted a solid piece of steel on the cutting edge, and I don't know which side is going to end up being the cutting edge. Alright, we've got a large block welded in one end, and that's going to be for some extra tang material. We have 1080 powder with 4% nickel, and we have some 1095 powder that should blend nicely in with those plates that we put on the side. We have our serpent, which is 3D printed, just white generic PLA for that, and it's just sort of my own design I came up with and drew that out. So just as an experiment for this, nothing special, pretty simple, so we can see how these lines come out. A whole bunch of stuff, but we are learning here, and when you're experimenting to learn, you never know what to expect. Okay, we got some tape on there to keep from cross-contaminating. We've got the 4% nickel powder in the serpent. I'll clean this up a little bit with a compressed air. Nobody wants a messy snake. No, you can't have that. Anyway, so we're going to get this in our can, and we got the tail end of the snake up against the big block. Hopefully that'll be the tang end, like we said. And we're getting this 1095 powder in here. We will get a little hand sander and compress that, vibrate it down inside. There we go. And we get this tape peeled off here. Get the lid on. We'll weld this guy up. Alright, so when I was welding it, I left one of the corners down here towards the tail end of the snake unwelded, so we had a little vent hole, a little tiny one. Alright, into the forge we go. And all I'm trying to do here is just compress this billet into a solid mass. I didn't want to distort things too much, so I didn't go too far with it at this stage. And we're going to see if we can get the just straightened out, and we'll cut the can off this so we can take a look at this billet and see what it looks like. And this can was not difficult to get off here at all. I used a pretty thick material on this can, so it was a little bit hard to bend, but it came off real easy. I had a couple of pits on one side, and we ground that flat, so we're good to go. So in forging this out under the press, I realized that later on, after I saw the billet, what was going on here is the areas that I did not forge down as tough in between those presses, the snake did not spread out as far. So it's a little wavy, and you'll see that towards the end of the video. We'll take a real close look at this thing, and you'll see what I'm talking about. But that's one of the things, if you're going to attempt this, find a way to evenly press it all the way around. I got this on the surface grinder, and we'll get it over and etch it a little bit and see what this looks like. And interestingly enough, our 1095 solid plates have a different contrast than the 1095 powder. Maybe one of you guys who's an actual knife maker can tell me how that works. I don't know. Anyway, get over here on the anvil, and I'm going to hammer in just a little bit of a bevel on the edge of this, mostly because I want to give the cutting edge a little bit of a curve. I think it just looks a little bit better that way. Alright, and we cut off the handle of that. We're into the power hammer. We're going to draw out a tang. We're going to draw this tang out pretty long and taper it. I want it to go all the way through the handle, and we're going to put a nut on the end of it. It's sort of an easy assembly method, and it'll give me the opportunity to be able to take this knife back apart, because there's some things that I may want to experiment with this in the future. So this will all be a mechanical connection, and the nut will hold all the handle pieces on and together, and we won't be using any epoxy at all. Alright, so we're going to get it over on the surface grinder again and flatten this thing out on both sides, and we'll have to take it over to the belt sander, the 2x72, to clean up the edges, clean up the profile, and clean up those bevels. But this was pretty easy. I mean, there wasn't a lot to do here. The surface grinder took care of most of it. We're going to hold on for a second here. Take a look at the tip of that blade. That's going to affect the outcome of the contrast at the end of the video. So you'll see that in a bit. Meanwhile, here's some gratuitous fire to keep you interested. Alright, so we're going to get this thing back over to the grinder, knock off some of this scale, and we'll get it in our tempering toaster oven. How's that? And we're going to put it in there for an hour at 400. I believe we did that twice. Been a while since I did this. It's hard to remember. And my favorite part, hand sanding. I never take it down far enough on the grit. I never polish it up. I'm just not patient enough. But we do the best we can. We'll get this in some ferric chloride, see what it looks like. And you're going to see this when it comes out of here. Take a look at the tip of the blade. You can see it's got a little bit different contrast to it. And that was from that overheat. So I don't know if this is another question. Would a retempering, reheat treat of that change that? I don't know. All the more reason to have a removable handle. In the future, we might try reheat treating this. Alright, we're going to drill out this piece of yellow bronze. Looks brass to me, but this is what's used in the commercial door hardware industry. And I call it yellow bronze, but it polishes up real nice. And this is all recycled stuff, so, why not use it? I recycle lots of stuff into other things, so. Okay, so I had to stop for a second and go look it up on Google, because this is going to be the bolster. Look at me go, learning all these names of these knife parts finally. Right on. So, rounding out some corners there. So this knife has some little rounded shoulder areas in it, because I didn't want to make sharp cuts there. So that fits quite nicely. And we're going to measure this up to cut it off for this nut. And because this is a flat tang, we're going to put nuts on both sides. This is the second time I did this. I started doing this one time and I didn't have the camera on, so do this again. I cut this piece of round stock to fit over this tang, and it's going to guide my die so I can cut these threads down onto the flat sides of that tang. I'll get some nice threads, and the flat tang will be able to fit through the handle and be nice and snug, and nothing will rotate around. In the butt plate, I guess it's called, that's what it said on the interwebs, I went ahead and just drilled a round hole, and the pressure against the wood should hold that in place. There we go. I drilled a hole in that guy. And I get this all assembled and put this nut on here, and it held pretty well. I was pretty impressed about it. Now the bolster, I took it off a little bit later and I peened it so it would sit a little more snugly around the blade. I did not show that process, but you'll see it towards the end of the video. Alright, we're going to attack this thing with a big grinder and get rid of the majority of this material. And this wood was pretty hard, so that's good. It seems to be that it's good to handle material. Alright, get it over to the 2x72 and finish off this handle. It's the easiest way that I found. Get rid of the bulk, and Champ Ironworks. Haven't seen you in a while there, buddy. Hope you're watching. Hope the family's okay. Good to see you. Anyway, We finish his handle off, sand it down, and I think I took it to 600 grit, something like that, by hand. And we're going to get some spray oil on this thing just to seal it up. And there we go. So we're going to take a little bit closer look at this, but before we do that, you kind of see some contrast in there. Anyway, let's give it a quick little sharp test and see how it does on a piece of paper. Let's drop it on the old pant leg. So this knife is definitely an experiment. It cuts really well, it holds an edge really well. Probably end up being a camping knife or something like that. No way disappointed in the way this came out. It is an experiment. I've done some things wrong, but it was a pleasure doing it, and I learned a lot of stuff doing this. So we're going to take a little closer look at this. This is kind of dark. Hold on. Let's lighten this up. There we go. All right. You can see towards the tip of this blade where it looks like the grain structure of the blade is much larger because it was quenched way too hot on that end of the blade. So you can see some of the lumps and bumps and wiggles in the serpent. That was from that forging process and the need to sort of forge it all at once, or press it all at once if you can, to keep that from happening if you're doing a 3D printed thing. Now I would think if I annealed this, re-quenched it, and then re-tempered it, that I might be able to get a more even contrast and get this large grain to calm down. One of you professional knife makers out there, let me know if that'll work. Alright guys, we're going to call it good for this one. Thanks for stopping by Big Dog Forge. Like, share, subscribe, and take care of yourself. Alright, be safe. We'll see you soon guys. Bye bye now.